Hello and welcome to this video in which I will explain the congestion feature in the GLE. Congestion is what specifies what other traffic than your own exists in the cell that we are emulating, and this congestion will limit the amount of bandwidth available for your applications. We remember the chart showing the data usage by your applications, but you can actually see what other users are using as well by hitting this other button. The red chart here is for other traffic. You can see it quite bursty, goes up and down. I have set the GLE to use a fixed bandwidth channel, 8 megabit per second. So your application and the congestion user will have to share this one. You see this point at time the other users are transmitting quite a lot, and your application just gets the CIR. At this point your application most probably does not require any data at all, so the others won't get a little bit more. At other times they share it. There is two types of congestion, what we call background load and burst load. Right now there is no background load, but some burst load. Background load is a easy, simple way to set up congestion. You simply specify how much data will other users of the cell use, and background load has highest priority in the cell, so it will simply limit how much is available for your application. I can, for instance, remove the burst load and set the background load to 75%, which is 6 megabit per second at most, and the medium I can set to 50%, 4 megabit per second, and at least 25%, which corresponds to 2 megabit per second. And again I hit apply to use these parameters, and on the status page I can see the effect of this. And most probably you should see a chart that goes from 2 to 6 megabits per second and vary in some random way. And again you can see the sum of these two charts should not go beyond the 8 megabits that I have specified for the cell. You can see at this point the background load used more than 4 megabits, so your own application cannot get the 4 megabits that is your MIR. At this point the background load is below 4 megabits, so your application can get the 4 megabits MIR. On the congestion tab we have a simulation down here which give you a quick view on how would these parameters influence your chance of getting a certain bandwidth. On this chart we have the bandwidth here, and here we have a probability to get that bandwidth. So we can see that the chance of getting 2 megabits per second is close to 100%, which is expected because the maximum is 6 megabits, the channel is 8 megabits, so we should always be able to get 2 megabits. On the other hand, the chance that we get 4 megabits is approximately 50%, which is again expected as the mean load for background is 4 megabits. The probability to get the MIR, we call the MIR level, it's close to 50%. The CIR level is then the probability that we get the CIR, and these are the figures that you can see here for both uplink and downlink. The other type of congestion is burst load, which is a more realistic congestion, and I'll demonstrate it now. First I'll set the background to 0. It's of course possible to have both kinds of congestion at the same time, but for demonstration purpose I will remove the background load. Then I will create a new group of burst loaders. You can have all the burst loaders that you want. Burst loaders will respect the priority of data, so burst loader might have lower or higher or same priority than your own. On the subscription tab I can see that the priority for my VLAN that I'm using is 10, so I will set this group of users to have the same priority. I could say that there is 3 users at most and minimum. These users I set to transmit burst of 4 megabytes, and we can put some deviation on the burst size, and let me say that they get to transmit 3 bursts per minute, and all these 3 users could have a MIR of 4 megabits and a CIR of 1 megabit. And hit apply to see what that would result in. And for our VLAN 1024 you can see it will look like this. MIR level is this case 32. We still have a CIR level of 100, and on the status page we can see what would the result be in the end. You can see these bursters here, and as they have same priority as our own users, they will have to share. We remember that we have at most 3 users. So at this point in time, this is probably 2 users bursting and our users, so they will have to share. So our users get just below 3 megabit, and the 2 burst users will get just below 6 megabits, and in total that is 8 megabits. I can set the priority for the burst loaders to a higher priority, a lower number, and that should have an influence on the charts here, because now they have higher priority, so they will sometimes get higher bandwidth and limit your bandwidth more. And as for the channel and the subscription, you can save and store these parameters in sets. And I think this concludes the demonstration of the congestion feature. Thank you.